and 10% go to colic. And for colic, 90% return back and 10% are returned to Bendigo. So there's a car company, you can rent from anywhere, you can return from anywhere, right? So that's how the transition is all about. Now, if I were to put this in a transition matrix T, in the world of transition matrices, I start with the columns. That's my present state or my initial state. So what's the initial state? You rent first. And what's the final state? You return. So I say rented from, and I say Bendigo or colic. And I say, what's the final state? Returned to Bendigo or colic. Now let's put this numbers here. Rented in Bendigo, returned to Bendigo. 80%. 0.8. Rented in Bendigo, returned to colic. Rented in Bendigo, returned to colic. 0.2. Your column total should always be 1. I don't care about the row totals. Rented in colic, returned in colic. 90%. When I know one number in my row, I don't even have to look at my transition diagram because I know it has totally to 1. So this should be 0.1. And that's the state anyway, right? Sorry, this was 20%, my bad. Oops. 10% here, right? So that's my transition matrix. My columns are adding up to 1. Now, I say that the starting point, once I've established my transition matrix, let's put some numbers around it. Let's say at the week 1, let's say this is a week by week transition. At week 1, there are 50 cars in Bendigo and 40 cars in colic. That's my starting point. At the start of week 1, or probably I said at week 0. So when I have my initial numbers with me, I create another matrix called initial state matrix, which is called S0. And I write these numbers as column matrices, column matrix. I say 50, 40. Is that clear? Now, I have my transition, week by week transition. This is weekly transition. I now ask you, tell me after the week 1, how many cars will be in Bendigo and how many cars will be in colic? So what you will do is, I'm asking you to find S1. So your S1 is the transition matrix T times S0. So in your CAS, define T, open your CAS up, define T and define an S0 and do a T times S0 and tell me what would you get. Did you get the exact numbers?
Yeah.
44 and 46. So that means at the end of first week, there are 44 cars in Bendigo and 46 cars in colic. After week 2, so now I will do, my transition matrix remains the same because that's how week by week the transition is happening. And I times it by the previous element. Can you give me S2, please? Whoever is ready.
I got 39.8 and
Yeah, that's fine. 39.8
and 50.2.
If the question in the exam asks you, find the number of cars at the end of second week, then once you've got that, you round it off. And you say 40 and 50, right? Because the initial was 90, right? So you have to match the total. But then if the question says, that's the initial state matrix, that's the transition matrix, find me the number of cars in week 3. So please do not approximate it. Approximation will happen in the end. So you will say T times S2, and S2 will be the decimal value. Can you plug that in and give me the answer? What is S3?
$36.86 and 53.14.
36.86 or 9 and
53.1.
53 point
14.
maybe
1.
1. Yeah? Now the question asks me what is S, find the number of cars in third week. Then you say, alright, this is like 40 cars here. And maybe like what, 53 cars or 50, whatever, right? 37 cars here. And this is what, 53 cars here. Right? Make sense? So my recursion formula now comes into the picture. Recursion of the geometric sequence. That tells me that Sn plus 1 is T times Sn. If you need to go to the next term, you need to have transition matrix multiplied by its previous term. You go to the next term. Easy. If I say go to S10, 10 weeks, then one way is you keep going. S4, S5, S6 until S10. You remember from the world of geometric sequences, what was Vn? Vn was r raised to the power n times V0. This was called the nth term formula. When you had the first term and the common ratio and the number you want and the term number you wanted to go. Or you had that formula which was Vn plus 1 equals to r times Vn. You had two formulas there, yes? Correct? This was the next term formula, which we normally use in recursion. When we say give me the recursive, the recurrence relation, I use this, but then that's jumping on directly to the nth term. Similarly here, in the world of transition matrices, that's the next term formula. Keep going. The other way is using this, and this is Sn equals to Tn times S0. Right? So now if I say, okay, give me the scenario here, Bendigo colic, 10th week, please, after the end of week 10. So that means S10. So you'll say t raised to the power of 10 times S0. Can you do that, please, quickly? Okay, so what is S10 now?
31 and 59.
Did you approximate it or give me the decimals?
Approximately.
Approximate it. If I say go to S10, 10 weeks, then one way is you keep going. S4, S5, S6 until. Do one thing now on CAS. Put an S. Can you just use this formula? Same transition matrix, same S0. Find me an S50 and S55 and an S60 quickly. And give me the decimal values, right? I don't need the approximate values. Give me the decimal values. And in case Ethan's not able to do that, then once you're done, you can just quickly help him, right? On the CAS, please.
I deleted the matrices.
All right. So your transition matrix T was 0.8, 0.2, 0.1, 0.9, and your S0 was 50 and 40. Handling CAS can be a game changer in the exam, right? Handling exam can be a game changer in the exam. Yes. Who's got the S50 for me? What's the S50?
I got 30 and
No, I need the decimal values as well.
yeah,
No approximation.
yeah, it was 30.000.
30 point?
00. It just keeps going 0.
Okay, and what about
59.9.
S55? 30 point?
Same thing.
And what about here?
Same thing.
What about here?
Same thing. Same.
You see what's happening? You're making changes week by week. So in the 50th week, 55 week, 60, values are not changing. The values are becoming stable. So when your matrix starts to throw the same whole number, your matrix has reached to a point which is called equilibrium state. So that means in long term, 50th week is a long term, 55th week is one year down the track, right? Long term, with all this transition happening in between Bendigo and Colac, 80% going to Bendigo, 20% going to Colac, and then 90% to Colac, and 10% to whatever is happening here based on this transition matrix. In long term, Bendigo will have 30 cars on an average, and Colac will have 60 cars on an average. So that's called the long-term solution, or an equilibrium state, or you say long-term solution. So in the question you would be asked, you'll be given a transition matrix, you will be given an initial state matrix, and you'll be asked, okay, find me S3 and S5 and S7. And then it will also ask you, in long term, what are these values? So then what you need to do is, you need to throw large values of n, 2-3 large values of n, and check the answer. So here I threw 50, 55 and 60, and I found these are not changing. They will change, but then they'll be changing at 6th or 7th or 8th decimal place, not immediately at here. So the whole number will still remain the same. Right? So that's called the long-term solution for any problem that you are trying to solve. Right? Or I call this as equilibrium state, or I call this a long-term solution, or I call it as steady state solution. They're all talking about throwing large values of n and giving the answer. So if the question in the Bendigo College example would have been like this, that okay, give me the first week, second week, and can you predict in long term how many cars will be there in Bendigo and how many cars will be there in Colic? So then you start throwing some large values and then test it and give that answer. Does it make sense? Yeah. Let's do a question